next unit is on basically, like, in general, it's called a unit on functions. Functions, we've worked with functions basically your entire math career. Now we're just going to define them. It's a really important feature with a lot of equations. And just to kind of provide some context into why it's important, we're going to actually start out by thinking about a vending machine. Okay, so a vending machine is actually an easy way to illustrate what a function is, because in a vending machine, right, what we do is we punch in a number, right, depending on what candy or what bag of chips or whatever you're trying to get out of there, you're going to input a number. Now that brings up one of the first terms involved with functions is the input. Okay, input is what we put into an equation, right? With equations, most of the time it's the x. Okay, with this particular analogy, with it being a vending machine, the input is the number. So number and letter. We'll just say number and letter. But really, it's the number and letter of whatever type of candy or bag of chips that we're trying to get out, right? And we know for sure that if we press A1, we're going to get, let's say, like one of my favorite candies is I love like the holiday Reese's. You know, like around Christmas time, they make the trees. Around Thanksgiving, they had, or no, Halloween, what were they? I just ate one. Huh? Yeah, the pumpkins. Okay. Yeah, like those are my favorite. Okay, so let's say that I want to get the Reese's that's in A1. Well, I plug in A1, the output is us actually getting the candy. So what's the output? The item that corresponds to the number and letter. Right, so when the vending machine is working correct, when I press A1, I know for sure I'm going to get that Reese's. And that's a good thing. What we don't want to have happen is we don't want to have to press A1, and sometimes that vending machine is going to give me that Reese's, but then another time it might give us what's like a candy that's not very good that a lot of people that I love Twix. Okay, a lot of people dislike Twizzlers. I like Twizzlers. I'm like you. I love Twizzlers. Okay, but I get it. Black licorice, right? Not many people like black licorice. Yeah, there we go. Okay, so let's pretend that I press an A1. I want to know for sure that I get that Reese's. But if sometimes I press that A1 and it gives me Reese's and sometimes it gives me black licorice, I'm not going to be very happy. That's the same idea of a function. When we put something into a machine or an equation, we want to know for sure what we're going to get. But if we plug something in and we might get something one time and something another time, that proposes an issue, right? I don't want to get that black licorice. I want to know for sure what the output is getting. So to illustrate, right now these are called relations, but to illustrate this relationship, I know the writing is super small. This is exactly what we're doing, right? So this is called a mapping diagram, where we have our list of inputs. Okay, so whatever we would plug into the machine, and then based on what we plug in, we're going to get corresponding outputs. Okay, so this is just one way to show a function. And here in a second, we are going to relate it to numbers. Right now, it's still relating back to that vending machine. We don't need to know what these are saying, okay, but that's just, again, that letter-number combination giving us different things in the vending machine. Now, another way to represent this relationship is with our ordered pairs. Now, we've seen ordered pairs before. That's like an x comma y. Since we're not necessarily working with just x's and y's, we'll say our input comma output. Okay, so all of these are ways that we can represent what's called a relation. And in fact, if we look at our next slide, it has that definition right there in front of us. Let's take a look at that vocab. Okay, so any pairing is just simply a relation. Okay, an x and a y combination, we'll call that a relation. The more specific relation that we're referring to with the vending machine is a relationship where each input has one and only one output is called a function. Okay, so another thing that we're going to look for here is that every x has one unique y, right? Or in the vending machine case, every input, so if we press A1, we want to make sure that we're getting the Reese's. Okay, so let's put an example right here. Okay, so let's say we press A1, that gives us the Reese's. This models a function, okay, where the input leads to exactly one output. A1 leads directly to that Reese's. When it's not a function is when we press A1, sometimes it gives us that Reese's, but then some other time it might give us that black licorice. Ooh, and me spelling licorice, I think that's right. Licorice. This is not a function because for this given input, we have two different outputs. This is a big piece of this lesson, and it's a very simple idea if we're willing to actually think about this definition, which might mean we haven't had to study much in here, right? Yes, you've had reviews and you've had practice problems, but there hasn't been a thing that truly needs some studying. This is the first concept or definition that you'll need to study, okay? And again, it's fairly simple if you just take some time to actually think about what it is we're looking for. And this whole lesson, we're going to practice what this exact concept is, okay? So we're going to have plenty of practice with it today. Okay, a few more vocab before we get to some examples. Independent variable versus dependent variable. Okay, so just like inputs and outputs, our variables, x and y, can be referred to as our independent and dependent variable. X is always independent, meaning we can kind of choose what x is, right? But the y value depends on what the equation is or what the function is. So typically, your output or your y value is considered the dependent variable as it depends on the x value or the input or the independent variable. Now, what we're going to identify in our lessons today is what's called our domain and range. The domain is the set of values for your independent variable or all x values. Okay, so domain refers to the inputs or the x values. And then range is a set of all values for your dependent variable, which is all the y values. All right, so again, this vocab and these concepts need to be studied. Don't just look at them today and forget about them. When you go home to your homework, make sure you know these again. Tomorrow when you come into class, while you're waiting for me to check homework, quiz your partner on, do we know what the definition of a function is? Okay, what the independent variable is referring to. All these things need to be studied. Okay. Let's move on from the vending machine problem. I've already kind of explained that part there. And let's get to the actual examples here, where we're going to determine if the given relation is a function or not. So when we see this, what this is asking, okay, determine if the relation is a function or not, what we need to answer, does every x, or input in this case, does every input have one output? If the answer is yes, then we would say that the given relation is a function. If the answer is no, then the given relation is just simply not a function. Okay, so right now, for an input of 0, it's saying that when we put in 0, sometimes we get 2, sometimes we get 3. That's an issue. That's just like in the vending machine, if I press A1, me getting Reese's and sometimes black licorice. We don't want that black licorice. Okay, so this is an example of something that is not a function. Okay, we need every x to have one y. Number 2, when I plug in 2, sometimes I get 0, sometimes I get 1. Right off the bat, that's already an issue. Okay, every x needs to lead to one y. So just like before, this is not a function. Okay. So one more thing we're going to do with this relation is state the domain and range. And again, remember that domain is the list of all inputs. Range is the list of all outputs. Your x values and y values. So down here, it is the exact same relation. So when I state my domain, we're just going to list out all the inputs. The only thing we're not going to do is list an input more than once. So like this 0, yes, 0 goes to 2, but it also goes to 3. But when we list the domain, we're just going to write it down once. Okay, so what inputs do we see? And it doesn't matter how often they show up. So our inputs are just 0, 5, and 10. Okay, and these squiggly brackets, those are referring to a list. So we should be using those squiggly brackets. I know it's not the easiest thing to make, but it's not like a normal parenthesis, and it's not a squared bracket. So do your best to mark it some way different. All right, then the range, or the outputs, are 2, 3, 4, and 5. Okay, so just a list of the inputs and outputs. All right, let's do the same thing for number 2. Inputs here are 2, 4, and 7. And the range or outputs is 0, 1, 2, and 3. All right, and then what I'm going to have you all do is work through number 3 and number 4. So for number 3 or number 4, the first thing I want you to decide is this showing a function. Either say yes, it's a function, or no, it's not. If it's not a function, be prepared to tell me why, okay, or to tell a neighbor why. Then on the next page, that's where you'll see 3 and 4 written again. That's where you're going to state the domain and range. Okay, so just do the next 2 slides. First, deciding if it's a function or not. Try to agree on a common answer within your group. Say, yes, it's a function, here's why, or no, it's not a function, here's why. And then state the domain and range. And I'll give you like 2 minutes. Should be a pretty quick thing. Okay. So looking at the first 2 relations, number 3, and more important is not only just telling me whether it's a function or not, but giving me the reason why. So number 3, we would say is a function, and the reason is just a definition. Definition being that every input has one output, right? So there isn't a single input here that's going to give us 2 different y values or 2 different outputs. If we're, again, back to the vending machine, we know that if we plug in one of these inputs, we're getting the exact same output. We're not going to get the Reese's or sometimes a black licorice. Okay, so this is a function. Again, focus on not only whether or not it's a function, but then the reasoning as well. Number 4, that is not a function. And the reason it's not a function is because -7, when I input -7, sometimes I get 8, other times I get 13. That is an issue. Okay, so always focus on that reason. That helps you make this concept, it helps you remember it. Okay, and then you don't have to next year be like, oh yeah, I learned what a function is, but I forgot. Okay, this is helping you make sure that you remember this going forward. All right, questions there. Okay, on either one, why it's a function or not a function. Okay, so then listing the domain and range, nothing to it. Hey, it is just a list. Again, do your best to make those squiggly brackets. They don't need to be perfect, but don't want to use regular parentheses or squared brackets and just list every number. They don't even need to be in order. It is kind of helpful if they're in order, but they don't need to be. And then the last thing there is don't repeat any numbers. Like even though -7 has two different outputs, I'm not going to list it twice within my domain. Okay, so one way to show a relation is using the mapping diagram. Another way is using a table of values. And we've seen table of values already. Now, to me, this makes checking for if it's a function or not a little more difficult because we don't have the arrows, right? With the arrows, it was really easy. If one input had two arrows, we knew it was not a function. Now we need to see, and basically what I look for, is there any input that's listed more than once? Or we could even make this a mapping diagram, right? When I get 3, that goes to 1. When I get 6, that goes to 2. 9 goes to 2, and 12 goes to 1. So this is a function. Every input has one output. Okay, we're almost done. There's not much more left. All right, number 6. This will be the inputs. This will be the outputs. And I'm noticing that -4 leads to 8, -2 to 7, 0 to 3, 2 to 4, -4, 4 to 7, and 6 to -10. Do we see any input that is listed up there more than once? No, so that's automatically a function. And again, every input has one output. All right. Moving on to just stating the domain and range. Nothing changes there. Okay, we'll just do this for 6 or 5, and then we'll skip 6. Okay, but for 5, if I want to list the domain, I'm just listing all the inputs. So 3, 6, 9, 12. All the outputs for the range, 1 and 2. Now, one thing I want to point out here, and this is back to whether or not it's a function, we're getting different output, or we're getting the same output more than once, right? But let's think about that in terms of the vending machine. When you see a vending machine, might there be multiple places that you might see the Reese's, right? It might just show up as A1, but it might also show up in A2. Everyone know what I'm talking about there? Is that okay? Yeah, right? We still know that if I press A1, I'm going to get that Reese's. I could also press A2 and still get that Reese's. So that's kind of the case here. When I plug in 6, I'm getting 2. When I plug in 9, I'm also getting 2. But that is okay. We know for sure that if we plug in those numbers, we know what the output is. It's only an issue if we put one input in and get 2 different outputs. So this repeated output does not affect us in terms of it being a function or not. Okay, we'll skip 6. We'll go off to 7 and 8. These graphs, they are so small and so hard to see, so we'll just do 1 here. And let's just not, we won't worry about 8. Okay, so first determining if it is a function or not. Basically what we're looking for is on all these points, there's a point here. These graphs are way too small. That's 3, 5, 3, -5. That's negative 2, 6. And then we've got one at negative 3, 4. And then we've got another one at negative 5, 7. Okay, but the idea is still the same. Is there one x value that has two different y's? And I'm not seeing that, right? Every x, 3, has a unique y. There isn't any x value that shows up more than once. So this is a function. Every x has one y. Okay, and again, I know those graphs are really hard to see. I don't love that. On the homework, it's not that small. Now, if we were to list the domain and range, let's just do that right here since we've written down all those points. Again, the domain is just a list of all the x values. So negative 5, negative 2, negative 3, and 3. And then the range. What y values do we see? 7, 6, 4, and negative 5. Okay. Last thing I want us to do. Number 9, I really like this question here. Make one change to make it a function. I'm going to call on a group or two. Okay, what can you do to one of these numbers so that it becomes a function? And then 10, just tell me, is it a function or not? So I know that one's kind of hard to see, but can you in your groups decide if 10 is a function or not? And if it's not, why is that the case? It's the last thing we'll do. I'll give you 1 minute. Okay. Number 9, who can help us out? How can we make this a function? What's one way to do it? Ford, what you got? Easy, right? Just change this input to be something different so that way when we see this 8, it doesn't lead to two different outputs. Okay? Is there another way that we could make that happen? Gemma, you said something. What did you say? Yeah, so just change the output. Julian, what's another way? Change the other 8. Yep, so change the other output there. The other thing that we could do is just make, go ahead.
You can make the outputs, the outputs different or the same?
The same.
The same, yeah.
Yep. Okay, that was the last thing I was going to add to it, is that if we change this 28 to be 23 as well, well, if we get a repeated input and output, that's okay, right? When we plug in 8, we're still getting that same output. So you could either change one of the inputs, or you could change the 23 to be, or 28 to be 23, or vice versa. Okay, lots of ways to make that happen. 10, is it a function? Nope. Right? There's a point where there's an x coordinate of 2 and a y coordinate of 8 and a y coordinate of negative 4. So that is not a function. There is a way for us to test graphs whether or not it's a function. We'll talk about that tomorrow. Okay, that is it for today.